Seagrass habitats have been described as the marine equivalent to tropical rainforests and are one of the most productive ecosystems on the planet. Within the Indian River Lagoon, historical trends in seagrass abundance and distribution are considered a reflection of the lagoon's overall health and ecosystem function. Between the 1940s and 1980s, the abundance of Indian River Lagoon seagrass declined by 25%. This decline was primarily a consequence of a reduction in the amount of life-sustaining sunlight reaching the seagrass beds and caused by a decrease in water clarity. Scientists determined the reduction in water clarity was due to an increase in sediment, nutrient, and chemical loading, which had accompanied urbanization of the east central Florida coast. For the past 30 years, improving water clarity to mitigate historical seagrass losses in the Indian River Lagoon has been the focus of federal and state regulatory agencies, university scientists, and a broad range of NGOs. The amount of life-sustaining sunlight reaching Indian River Lagoon seagrass beds will also change as a consequence of rising sea level. Prior to this investigation, potential changes in Indian River Lagoon seagrass distribution caused by rising sea level had not been investigated. This video summarizes the results of that investigation, completed in 2014 and funded by the Indian River Lagoon National Estuary Program. The study area is that portion of the Indian River Lagoon managed by the St. Johns River Water Management District. This includes the northern and central regions located in southern Volusia, Brevard, Indian River, and northern St. Lucie counties. The project was completed in 3 phases. In Phase 1, seagrass habitat response to sea level rise was simulated within the existing basin. The shoreline was held at its present location, so only the depth of the lagoon changed as a function of rising seas. In Phase 2, the flooding of undeveloped land adjacent to the lagoon shoreline was simulated, and potential habitat gains quantified within new estuarine open water environments created by rising seas. Finally, in Phase 3, the results of Phases 1 and 2 were combined to simulate net change in seagrass habitat as the lagoon both deepens and expands under conditions of rising sea level. This video summarizes simulation results representing a sea level rise of 2 feet and 4 feet, now likely to be reached by the year 2050 and 2100 respectively. Seagrasses typically thrive in shallow, sunlit waters. As water depths increase, the availability of sunlight decreases, and at some critical depth, light levels are not sufficient to support photosynthesis. This limit has been quantified throughout the lagoon and is termed the median depth limit. Within the study area, the lagoon has been subdivided into 18 segments, each distinguished on the basis of its median depth limit. If water depth increases or water clarity decreases, the deep water edge or median depth limit of a seagrass bed will migrate into shallower water. When the shoreline is held constant, as in Phase 1, this ultimately yields a loss in seagrass coverage. These losses may be offset by potential habitat gains in newly submerged wetland and upland areas if the substrate is suitable for colonization by seagrass and if water depths are less than the median depth limit. These potential habitat gains were simulated in Phase 2 of this investigation. The Phase 1 starting condition was the year 2009, when approximately 29,000 hectares of seagrass were present in the study area. A 2-foot rise in sea level reduced seagrass coverage to 40% of the starting condition, and a 4-foot rise reduced seagrass coverage to 7% of what was present in 2009. A comparison between the northern and central regions of the lagoon indicates vulnerability to sea level rise is similar. Phase 2 results indicate potential seagrass habitat gains in newly created estuarine open water areas after a 2-foot rise in sea level are equivalent to 26% of the 2009 starting condition. A 4-foot rise creates potential seagrass habitat equivalent to 88% of what was present in 2009. More potential seagrass habitat is created in the northern region as a consequence of the presence of extensive natural and protected areas on Merritt Island. In the final phase of this study, the net change in seagrass habitat induced by rising sea level was simulated by combining the results of Phase 1 and 2. These data suggest potential seagrass habitat available after a sea level rise of 2 feet is equivalent to about 60% of what was present in 2009. A sea level rise of 4 feet yields potential seagrass habitat equivalent to 95% of what was present in 2009. Again, the differences between the northern and central regions reflect the presence of extensive, undeveloped, low-lying conservation lands on Merritt Island. The results of this investigation indicate the resilience of Indian River Lagoon seagrass under conditions of rising sea level is strongly dependent upon the availability of undeveloped land surrounding the existing shoreline. At present, resilience is more robust in the northern region of the lagoon, wherein roughly 80% of the land submerged by rising sea level is in the Florida Natural Areas Inventory and currently protected from development. By contrast, only about 30% of the land submerged by rising sea level in the central region is currently in the Florida Natural Areas Inventory. In September of 2014, project investigators met with staff members representing conservation land management and acquisition programs within the study area. These meetings were designed to convey the results of the investigation and importance in protecting existing undeveloped lands adjacent to the shoreline as a means of facilitating the resilience of lagoon seagrass under conditions of rising sea level. This could be achieved, for example, by updating their respective land acquisition strategies to prioritize unprotected wetland and undeveloped uplands identified in this investigation as potential seagrass habitat. This type of targeted land acquisition will help to ensure the resilience of Indian River Lagoon seagrass under conditions of rising sea level and their continued contribution to our quality of life.